Okay, so welcome to 6950. This is a course in scientific computing that we offer at Memorial University. As I said, we're just talking course organization. I'm going to use Zoom as my way of interacting with you. Um, Hopefully, you're able to join us on the 2 afternoons a week for the next 6 weeks as we plow through some of this material. The basic theme of this course is trying to equip you with some of the skills and technologies and knowledge that you need to be able to use high performance computing in science, in computational science. Computational science has touched just about every area of science and engineering that there is, and that's a very broad definition. There's a whole field of digital humanities now out there which uses these skills. If you've ever heard of anything about data science or the big data or artificial intelligence, machine learning, these are all subjects which touch on the tools and the tool chain that we're going to be interacting with in this course. Now, saying that, in terms of who's in this course, there are some people who begin a master's degree in science. It could be chemistry, biology, physics, ocean sciences, engineering, statistics, but they don't know how to program. They haven't really done that. But the reality is to do modern research, we're interacting with computers, right? So how do we actually use these things in a scientific sense? You're all, I'm sure, very computer literate. You can use Zoom, you can use Facebook, you can use Microsoft Office and that suite of applications, but those aren't always the tools that we end up using when we're interacting in a scientific way with our computers. We tend to have as a primary way of interacting with what we're doing, and I'll see if this is going to work. There we go. Something that looks like this. This is called a command line or a shell or a terminal. That's sort of the default way that when we're talking with high performance computing, whether or not it's the machine that we're physically on or some remote machine, that's what we tend to interact with. And so today's topic session or whatever is going to be going over, okay, what do I do when I'm presented with this little flashing cursor in the middle of my screen? How do I make it go? How do I make it work? So we're going to cover that in terms of an introduction to the shell, try and do as much as we can over the next 3 hours. And then we'll proceed in the course is we'll talk about some specific technologies, things like version control, scripting languages, most likely Python, some visualization, and then some things like databases, cloud computing, different software packages that are out there. This is a course, so I need to have an evaluation, some sort of way of organizing through the course. And so, in terms of how we're doing that, or how I'm going to organize this as a course, where is that button? So, should you share? So you should, if you are following along with if you're enrolled in the course, as almost all of you are, there is a online.mun.ca page associated with this course. I'll use this for the grade book, but I'm not going to really use it for communications. So I'll post official announcements in here. But as I've been saying, almost all of the back and forth communication, we're going to use something called Slack as the primary way of communicating with the course. So most of you, if not all of you, should have received an invitation from me, and I see many of you have already joined it. I'm going to use Slack as the way of doing asynchronous communication. So you've used programs like Zoom and WebEx before. You know there's a chat feature in those. We're not going to use the chat feature in Zoom. We're going to use the chat feature or the interactive thing in Slack as a way of communicating. And as I posted here, usually if you have something to use, say in the class, if you don't want to speak it out loud, just use the general channel on Slack. And this gives a chance for everyone in the room to hear the question. Maybe they have that question. Maybe they have an answer to the question or the comment, and I might not look at it, and that'll be faster. Obviously, if there's something personal and you want to interact with me, then go ahead and send a direct message on Slack. It keeps things sort of organized. I'd rather not use the messaging feature on Brightspace. So Brightspace online.mun.ca has this ability to send messages and things. I'm not using any of that. It's I don't find it a great way of interacting. You're already here. You're on Zoom, so you have the Zoom link. We'll use the same Zoom link for the next 6 weeks. If at any time you need to have a one-on-one meeting with me about this course outside of the lecture time, it'll be this Zoom link. We'll go all the way through. In terms of what you need, you need a laptop, a desktop, a computer. It doesn't matter what operating system you are running, whether or not it be Mac OS 10 or Windows or any distribution of Linux. You have to have that. You have to have internet access, and from there, we'll be able to set everything up. Okay, so let's just do a little sanity check here as we're going. So hopefully you've had a chance to go into this online.mun. You've read sort of the opening synopsis about the course. Oh, incidentally, a grading scheme. Every lecture I'll have some sort of assignment for you to complete. Could be a participation thing. You've done the exercises. Could be a little email back. Could be something larger. I'll grade half your mark based on doing that kind of work. 10% on participating. That just means interacting on Slack, attending the class, presenting a solution if I ask you to from an assignment. This is not a big deal, but it sort of sorts the students out a bit. And then in the last sort of 2 weeks of the course, we'll do a project, something that incorporates all these tools together. Okay, so let's just do a little quick check in terms of what's going on. I'll show you how I've organized what I'm looking at. So generally, like if you can sort of see, hopefully, my entire screen right now. So I've got a couple of windows open, right? So I have Slack here on the left. I've just pushed it there so that I can see it all the time. And let's just do a quick little check. So if I say hi, CMSC6950, things like that, can you respond to this? Is this working? Like if you go and you jump in on that thread, does that work? Are you able to use Slack? Are you logged in? And my hope is I'm going to see a lot of responses on that thread popping up. Oh, okay. There you go. There's some highs. So this is good. This is good. So the thing about Slack is this can really quickly do a lot of stuff. When there's a topic, like you want to respond to a particular question, the thing is about interacting in these systems is there could be multiple discussions going on at one time. So one way of using it well is when someone says something, think about that as the beginning of the conversation and continue the conversation in what's called a thread. So over here, you see view thread. Well, this is like a sub conversation that was launched because I made that first statement. So you don't have to do that. If it makes more sense to you to put it in the main channel, that's fine. But generally, if you're trying to respond to a particular question, try and respond in a thread. And the way that works is you take the message, and then you can say reply to thread. I'm just hovering over it and doing that so you can get some sort of feedback, just organization. So I'll try and have this open at all times so I can sort of see people wanting to interrupt me. If you notice something like, hey, James, your voice went away, we can't hear you, you could drop a note in there. I'll try and pay attention to that. I've also got Zoom open here on the right in case someone pops up and gives me a face, but I'm not going to look at it too much. I assume you may want to have Zoom open so you can see me and whatever I'm screen sharing. Now, obviously, your screen, you're going to want to rearrange your windows so that you can see whatever I'm screen sharing. Slack. And I'm today going to focus on this terminal at the top, and we'll do some stuff. And then I've always got a web browser open because I got my notes in there. But for the purposes of what we're doing today, what I'm going to do is focus on just this terminal. So okay, so we're going to start with this terminal. Okay, so before we get into this, I got some questions for you. Here's my first question. I want to sort of get a sense on who do we have here in the room? I've got 21 people registered for the course. I think about 15, 16 who are joining us today. Where are you coming from? What academic program are you in? So what you should see on Zoom is a poll that's propped up. And I don't know if you've got to log in. And I just made a list of the type of courses, programs that I know people historically take when they're coming from this. So several of you are going to be doing a master's in computer science. I know that. Some of you might be in scientific computing. Apologies to those in the general sciences, physics, oceanography, biology, chemistry, biochemistry, who are like, why don't you be more specific? A few students that geosciences. If you're in science, I don't think anyone's in engineering taking this course, but you never know. There could be someone in business. Okay, so I got 13 out of 16 who have voted. The other 3 of you, are you around? Okay, so anyways, I'll show you where we're at. So this is not the entire course. This is the 13 of you who chose to respond and who were able to join us today. I would sort of like the number to be closer to 21 people showing up most of the time. It's just better for conversation. You'll see that most of you who are here right now are actually doing a master's degree in computer science. Okay, so here's the history of this course, right? This course exists to equip people to do science with computers, which is, as you know, not the same thing as computer science, right? If you're doing computer science, you're learning algorithms, you're learning programming languages, you're learning operating systems, compiler design, data structures. This isn't that kind of course. This is a scientific computing course with the expectation that someone's mic just got turned on. If you want to leave your mic off unless you want to talk. So the people who are from computer science, I just want to have a little bit of a conversation of why did you sign up for this course? So because we're gonna do things, we're gonna spend like 2 lectures or 3 lectures on basically introduction to scripting, right? Python 101. Because some students have not done that before at all. And I just want to make sure that those who are doing a master's degree in computer science don't feel like terribly bored. So I said, if you're from science or business, I totally get why you're coming to this course. You should. That's totally for you. Those who are from computer science, and lots of people from computer science have taken this course before. It's okay that you're here. I'm just trying to get a sense of what your expectations are and why you chose to take this course. And I said, you can just turn on your mic and tell me, throw something in Slack. I'm just trying to balance it. Here's my background. In this group, there's going to be some of you who are new to the idea of programming, command lines, interacting with things. And there's going to be others who are doing theses in computer science, and you've actually worked jobs doing programming live. And I'm just trying to balance those 2 groups. So some people are typing. Okay, so someone's doing a PhD in mobility data. Okay, so the data and accessing data is important. This is good. I saw like 4 people typing and then they didn't hit enter. Go ahead. Be broad. Be brave. Either turn on your mic, give me a response, or learning about the more of Unix guys. Yes, exactly. Okay, because Unix, Linux, that kind of stuff is a lot of how we deal with things. I'm just watching people chat. Okay, so this is good. This is part of what I wanted to figure out. Someone doing pharmaceutical sciences, molecular dynamics. Okay, Karina, you are like my target user. You're exactly the kind of person when I designed this course I was thinking about. You've got someone who wants to do computational science. I'm aware of a few of the applications. people do things with like the protein database, and you want to download files, and you've got to interact with a shell, and I want to bring you up to speed. Okay, so that's one sense. I haven't really got an answer from any of the masters in computer science people. I know you need courses. I just want to make sure that you're not going to be relearning stuff you've already done. Okay, let me ask a slightly different question. In terms of making sure that you haven't seen this information before, have any of you either completed before a software carpentry course or are currently enrolled and in doing some of the AceNet training that's out there? And if you don't know what that is, just say no, and that's totally fine. So AceNet is our local consortium that supports high performance computing. It's part of what called Compute Canada, which is all the very biggest computers we have in this country for research and development. And they do a little bit of training to use their systems all the way through. Okay, 14. I'll show you where we're at. Okay, so this is just fine. The two people who we've either done software carpentry or currently are going through the training for, I don't know, 2 of our classes, you're going to go, well, wait, I already know this stuff. Yes, it's the same source material in the sense that AceNet training hasn't been going on forever. We're drawing from the same sort of big body of knowledge. My only difference is I'm hoping to go a little bit deeper in this course than you might have gone through in a software carpentry course or in that initial AceNet training. But if it's review for you, put the course on double speed and just browse through it and be like, yeah, I did all this before. I won't make you do work you already know, but there's going to be some crossover in, especially the first session or two. It's the same base information, but that's fine. I just sort of wanted to get a sense of where people are at. Okay, I got one more poll for you, and then we'll get into sort of the shell stuff. Which is, what are you actually using? So in front of you right now is a desktop or a laptop or something. I guess you could be using a tablet. I haven't really planned for that. What do you use? And I know you might have like 6 machines. What are you using for this course? Okay. This is the snapshot, and this is normal. This is exactly what I'm expecting. There are a few of you in the class who are running a Linux machine. Okay, great, fantastic, you're set. If you're running a Linux machine, you already know what a terminal is. This is not strange to you, or at least it shouldn't be if you're trying to run a Linux machine. If you're running OS 10, if you're running a Macintosh Apple product, you've got almost all the software you need already built in, and life's not hard at all. So if you're running OS 10 or Linux, you probably know how to start your terminal. Now, if you got a Mac, you may go, well, what do you mean terminal? How do I do this? If you go to the Finder, you go to Applications, you go to a subdirectory called Utilities, you're going to find an app called Terminal. And when you run it, you're going to get something that appears like this this screen right here, where you can type stuff in, right? You can type in things like uname, and it will tell you what kind of operating system you are running, or uname-a, and it'll tell you I'm running Linux on this machine and it's this version, right? If you're in OS 10 or Linux, I'm sure you're okay. If you're on Windows, this may be something you're like, well, I don't quite know how to do that. Now, way back in the day, you may have been familiar with something that sort of looked like this, and this depends a little bit of your age and your background. If you ever remember DOS, the disk operating system, like before Windows was all graphical, and this is getting older and older. there was a way, so I'll go back to my whole screen so you can sort of see everything that's going on here. There was a way of interacting with something that sort of looked like a terminal. And historically, like way back, if you ran a program called CMD, this is called the command prompt. And it's sort of like the shell we're interacting with. It's a way of typing commands in and getting stuff interactively. We are not going to use the command prompt. That is not the right technology for what we're dealing with. If you are working on a Windows machine, and again, if you're on OS 10 or Linux, don't worry about it. Almost for sure, what exists for you and works is something called PowerShell. Okay. So if you go through your start menu and you search for it, you just type here to search if you're on Windows 10, you probably have something called PowerShell. Okay. PowerShell is a modern POSIX compliant shell as opposed to CMD, which is another type of shell, but it doesn't have the same features. Okay. Shells are software that lets you interact with your computer. And there's different things you type in, but there's things they can and cannot do. Command is a different shell. PowerShell is a different shell. We're going to be using in this course a shell called Bash. Bash doesn't come built in on Windows. Now, there are ways of installing Bash-like functionality on a computer, on your Windows computer. And that's what I've done right here. So this computer you're looking at right now, this is a Windows machine, right? So I am currently WinVer. I am running a Windows 10 machine, build 21376. That's what I'm running. And even though I'm running that, I have a Linux kernel running within my machine. And this is a feature that developed, 3-4 years ago on the Windows platform. You might be familiar with things like virtual machines or VMware, virtual PC, different applications to have an embedded system. I'm using something called Windows Subsystem for Linux, and it is really nice if you happen to be in a Windows environment and you want access to a command line and all that kind of stuff. Soon enough, we'll get you to install that. But I don't want anyone to get stuck today about following along and you don't have it. So what I've done for you is I'm going to get you to type in this command. And crossing my fingers, I think this works for everybody. So it doesn't matter if you are on Linux, OS 10 using terminal, or you just have PowerShell. My hope is, and this is again, crossing my fingers, if you type in your MUN ID, and I've gone and created accounts for everybody, so whatever your MUN email name is, right? Put that, and then log in to the following machine. Okay, so hopefully you get not an error, but a warning that looks something like this. And again, you're not going to type in J Monroe. If your name is Bill Smith, it's probably bsmith@CMSC6950.monroelab.ca. I just created a computer for the course. Do you want to continue to connect? You type in YES, yes. I've logged into this one before, so I'm going to say yes, I want to continue. That will never have happened to you. It's going to ask for a password. Okay, so here's the big thing. So 6950 Monroe Lab. Here, I'm putting something in. Okay, we're doing that here, and here is the secret password. Your guys are going to be so impressed with the complexity of the security here. There in Slack is the top secret password. It's not that top secret. I just need to create accounts for you. So you should be getting something that looks like this. Okay, I'm gonna do it. So you should be having something that appears like a little prompt. Okay, your username, the name of the machine, which happens to be CMSC6950. And if you typed in something like uname-a, you'll find that you're running currently on a Linux computer. Okay, it's an honest to goodness Linux computer that's not on your machine, it's somewhere off in the web. I said I spun this up for this machine. Now, this should work from PowerShell, should work from OS 10, work from anything. I'm hoping you're all there, and I can tell you're there or not. Okay, here are people who've been able to log in. This is good. This is good. Here are the accounts that I've created for everybody. Oh, you can't even read that. Well, that's terrible. I don't like that. I'm going to switch to a different shell, a different terminal application, but hopefully you can come along and join me. Oh, we're getting a few more people. I'm trying to get this list to like 13. I want you to do this with me. So you got a computer, you got a terminal, PowerShell, at least if something, and yeah, it worked for me. Good. This is good. I can see that it worked for you. Well, see, I need to match up names. Oh, we're getting a few more people. This is great. We're getting more and more. Now, because I'm screen sharing, this font is sort of silly. This program that I'm showing you here, PowerShell, I'm not really using PowerShell anymore. I'm just using the terminal application that PowerShell runs. And I just don't like it as much. So instead, what I can do is I can use a program to open up a terminal. Now, this is something that please install after the class. Don't worry about it right now. I'm using something called Terminal. Okay, so again, if you're on Linux or OS 10, you already have this application. This is a program called Windows Terminal. Now I'm using the preview edition in the sense of if you happen to be on a Windows machine, again, this is only Windows, and you were to go off to the Microsoft Store, you know how you install software in this environment, and you were to search for an application. Whoa! So I'm jumping around too much here. Search, and we search for Windows Terminal, right? Now there is the terminal version and the preview version. I don't care which one you use. I like to be on the latest and greatest, so I'm selecting the terminal preview version. At some point, you may want to install this. It just gives you a better look and feel. You've got tabs. You can change the colors. That's all that it really is. But we can do the same thing. From here, I can go SSH into this machine, type in my super secret password, and now we can see who's logged on. Okay, so far, we've got me logged in twice, and 1, 2, 3, 4, 5, 6, 7, 8, 9 people logged in. 9 is not the number of participants in the class. Talk to me. Turn on your mics, turn on your cameras. Who's struggling? Okay. 2 of you have give me a chat message in Zoom. So I'm going to respond back to each of you in this sort of way. Please use Slack. Okay, and that's because I'm not checking the chat in Zoom. So if you ask the question in Slack, please ask it again in Zoom. Please ask it again in Slack so that I can actually see that. Can you show the login code again? And this is why we're using Slack. Is there it is right here. You have a whole history of our conversation. You're going to log in. in Slack. Okay, I'm not sharing my whole screen. I apologize. Screen, share. You can see it. Just see it right here. Copy the username in. So you have to replace it with your username. And again, if you don't know your username, these are the accounts that I've created. So hopefully one of those names, you're like, oh, that's me. I recognize that. Can't input the password, does not type. Okay, so, oh, Ada, you have the same problem. Okay, so here's the thing about passwords. They're secret. We wouldn't want someone standing behind you typing your password in. So when you go to log in, okay, and ask for my password, it's not going to show up on the screen. Can you imagine if I was screen sharing and as soon as I typed in my super top secret password, you all see it? That wouldn't work out. So even though you're typing, it doesn't mean it's not working. Passwords are always hidden. You type it in, and then you're good to go. Now, copying and pasting it, that's a good solution. I'm fine with that, right? So how we doing now? We're doing a little bit better, but we still are nowhere near the. Okay, okay, this is good. This is good. Karina cannot resolve the host name, no such name. That's just your ability to copy and paste, okay, or read. So the course is CMSC6950.monroelab.ca. You typed in CMSD. Can you see the difference between those two things? Okay, so I'll close this up, and we'll just wait for Karina to get in here and join us. Aha, success. Okay, this is great. We've got 15 users. We're going to call this a win. We're set up. We're ready to continue to the next point. I know this is like, oh, it takes a long time to get going, but these are exactly the challenges that we're trying to solve. Okay, now it doesn't matter what computer you're interacting with. If you were doing something on Compute Canada servers, you would connect to a remote machine in much the same way. By the end of this week, you will be running a piece of software like this on your home machine, your desktop, your laptop, so that you have that. And what we're going to do is begin to learn, what am I even looking at when I look at this stuff. So where I'm at right now is the hope that at least for the 15 users, the 13 of you who are playing along at home, you are all staring at this thing. So really simply, this is a shell. Okay, so what shell am I running? This is called Bash. Bash is the born again shell. It's a way of typing things into a computer and it gives you information back out, right? So we type in commands using the keyboard and it gives us visual feedback on the response. The program that takes in those commands and spits them back out is called a shell. A terminal is the application that's actually drawing the window. So when you run a terminal application, whether it's Xterm or Windows Terminal Preview or some other program that draws the windows and the menus and the scroll bar, that's the terminal. And what that's doing is it's emulating an actual physical terminal. You know, back in the day, big mainframes, we didn't have desktops everywhere. What people had were physical machines with screens and keyboards, nothing else, just the screen and the keyboard, no computer. And what that device was called was a terminal. And what you did is the keyboard and the monitor would plug into a wire that would go to a computer, maybe in another room, maybe in another building. And that whole device allowed you to interact with a remote computer. We've virtualized all these things now. So applications that create the window that you can type into is called a terminal. The program that's running on the remote computer is called the shell, and it's the one you're interacting with. Now, in practice, people use the words terminal, shell, command line, all interchangeably, but there is a subtle difference between them. Okay, we've got something set up. We're able to proceed going, okay, what do I do? And again, if you're a Linux person here, you may just want to put me on, not necessarily mute, but sort of just keep me on the side. I don't need to play along. However, if you're like, no, I'm not an expert at this stuff, Play along. Just try and see what you could learn. At any time where you have a question about what's going on, let's use this time to work on it. Okay, so what is the shell? The shell is a very expressive way of communicating with a computer. You know, computers only understand code. We build a lot of software with graphical user interfaces, menus, mouse pointers, clicks, touchpad interfaces to try and make it easier for us humans to interact with computers. But as a way of sort of talking to it, even though the computer doesn't understand the shell, it's a lot closer. And what that means is we're able to be more expressive with what we're doing with it within terms of the computer. It's now an older movie, but do you remember? Do you remember seeing? Let's just do this thing here. No, I don't want to see the ad on. No, go away, ad. No, I don't want. Skip the ad. Skip the ad. Mute. Okay, I'll just do it here. Like this is now a historical classic movie. That. Do you know what scene of what movie that's from? You got it. It's The Matrix, right? Now, if you watch this movie, and I realize it's now like a 20-year-old plus movie, one of the lines was from the movie is you can't visualize the raw code. You got to look at it in this encoded way because it's too dense. There's too much information. I have no idea what this tells anybody. But the way that I like to think about a command line is sort of like the way to see what the computer is doing on the inside. You can't just look at the visual graphical rendering. You need to see what's going on. In some ways, that's what the shell is like. It definitely doesn't look as weird and interesting as the Matrix, but it's that kind of idea. We're doing that kind of interaction with what's going on. Okay. Another reason for using a command line interface as opposed to a graphical interface is what's called reproducibility. In the sciences, there is a growing problem with people writing research level papers. You publish a paper, you send it out there, and someone going, well, I can't actually replicate or even reproduce your results. Replication usually means devising a new scientific experiment to come up with the same results. Reproducing is even simpler. It's just like, can I take your analysis and run it again on the same data to get the same answer? And there is increasing evidence that a lot of papers out in the scientific literature are not replicatable. They're not even reproducible. And often that reproducibility can happen with your own research, right? You can imagine you did some work, you took some data, right? You downloaded a file, you loaded it into Excel, and then you cleaned the data up, right? You pointed and you clicked it and deleted rows and you added columns and you massaged it in some sort of way and you got your results. And then some time goes by, 6 months, 2 years, some gives you some new data. And all you need to do is run the same analysis on that data set again. The experience of most people is trying to reproduce what you had done with a point and click interface is at best poor. Usually it just doesn't work at all. You can't do exactly the same thing. We don't, like, let's say you recorded yourself with a video. Being able to know exactly what you did in a graphical sort of way, it just doesn't capture it. Furthermore, when it comes to actually reproducing it, to go through all the pointing and the clicking again and again and again, it's just not very efficient. So a terminal is just much more efficient. Again, I'm seeing my... someone is communicating with me on Zoom. Same problem. Okay, so what's... I just want to make sure... Apple app. Okay, sorry. I thought we would move this forward here. I apologize to everybody. Xing Yao, what's the same problem? So this is where cannot type the password. You type the password, but you won't see anything on the screen. Your keyboard is working. You type in the letters and hit enter. Right? The password is hidden so that no one can see it. And this is an aside. Whenever you're dealing with a computer issue and you're trying to get support for it, it's really helpful to me, to tech support, to a colleague, always show someone the complete error message. Okay, I'm going to give you an example. So imagine here I'm on a computer and I'm trying to log into something. Okay, SSH. Okay, and I type in this. Okay, saying this didn't work is not really useful. What would be better is to take that whole block of text and dump it over into Slack. Right? And actually copy and paste exactly what you typed in and exactly what the error was. Right? And then I could come along as a person to help and see a few mistakes. I'd be like, oh, you got an extra digit here. You didn't type that incorrectly. Or your username isn't correct. So when you're doing a question like doesn't work or I have an error, get in the habit of copying and pasting the actual thing you typed in all the way through. So I'm still waiting to figure out whether or not Genyo's in yet. You're probably feeling a little bit lost and it's not working. So I don't want to leave anyone behind, but Jinyao, are you able to figure this out, or do you want us to help you before we continue? This is one of those moments where a microphone and an audio actually would be really helpful. But I won't put you on the spot. I'm sure you'll figure it out, or we can talk after class. Okay, sorry, back to the content. Okay, so a terminal, a shell, is a really efficient way of interacting things, and it lets us reproduce things again and again and again. I'll give you 1/3 scenario why we care about things like shells. Imagine you're doing a workflow where you have to download some data. Okay, so I'll give you a very specific example of something that I encountered a student doing. We'll just go to, well, I need a new window. I'll give you something very specific so you get a sense of what I'm talking about. New tab. Okay, so this is just a web browser. Okay, so I remember working with a student who needed to do something with climate data. Okay, and what they were doing is historic Canadian data. Here's what the task was that they were assigned. Okay, they were told, I need historic data for all of the stations in Newfoundland and Labrador, and I want you to download the data. And so what they did is they went to a website and they were like, oh, okay, I've got to find the data. So they use the web browser and they're like, okay, Newfoundland and Labrador, search, great. Okay, here is all of the data from every weather station that happens to be in Newfoundland and Labrador. They would click on the button, they would get some data, and they'd go to download data, and they click download. They got a file. They double click and open it. They'd copy and paste that row into Excel, and then they'd repeat. And then they went to the next one, and they went go, and they went to CSV, and they downloaded the data, and they opened it in Excel, and they copied and pasted it to an Excel, into their spreadsheet. I think it was about 3 or 4 weeks of effort that this student went through. Okay, and it works. After the student had completed this, I was doing a little talk and we looked at an example problem. We started, completed, and finished the task in about 45 minutes using the shell and programming. Way more efficient. So these graphical user interfaces are great for discovery and exploration, but as soon as you find yourself doing the same thing again, like again being more than 2 times, start to think about how you can use tools like command lines and programs to accelerate all that. Okay. So all this is just to motivate why we care about kind of things. Okay, so what do we do? What do we do with this? So there are a sequence of commands that people are just supposed to know when you're interacting with the shell. So here's your first one. It's called PWD. Okay, it stands for Print Working Directory, and it's a way of figuring out where you are on your computer. So I am in the home directory in the account J Monroe of this directory. And what I can do is from this directory, I can move around to another directory. Now, to be able to move around, I need to know the names of the files I want to change to. Remember, this is a textual interface. You have no graphics at this level. So PWD, print working directory, ls is listing, or list the files that are in this directory. So if you type in ls, you should see a directory called data-shell. I know it's a directory because it's been colored in blue in this terminal. If you happen to be working on a black and white terminal, type in ls-F, and it will put a slash beside everything that happens to be a directory. This idea of a command and then options is inherent in terminal-like applications. All programs have these options you can pass in, and the -F option puts slashes at the end, so you know that the directories. The idea of a directory is then I can change the directory to go into this directory to see what's inside of it. So inside data, SHEEL, I have changed my directory. So now if I do PWD, you can see that I'm currently in the directory of home, jmonroe data.shell. I can do another listing, and I can see that inside this directory are 1, 2, 3, 4, 5 directories and 3 files. Again, if you did the -F, you'd see the slashes to make it clear that those are directories. Well, if I had some data, I could go into my data directory, do another listing. I could go into a protein database and do another listing. And here's all my files. The point is, this whole thing is the path you get to your files. Now, you're familiar, I'm sure, in Windows or Linux or OS X with the idea of a file manager or a file explorer. You click and you double click on directories. This is what we're doing. We're just doing it purely textual. So far we've learned 2 commands, PWD and listing. There are a number of options that we can use for these programs. ls is a program. Its purpose is to show you what's inside the directory. I've already talked about ls-F. What it does is it lists it, and if there is a subdirectory, it puts a slash behind it. There are additional options, and one of them is ls-L. What that does is it gives you the listing with a lot more information. Okay, what are we seeing? Well, what we're seeing is the date the file was created, how many bytes it is, who owns it, and you should own your own files, and then permissions. And we'll talk about permissions later on. That is one way of looking at the listing with a bit more information. And here's one more. If you do a ls-A, you will see all of the files, including the hidden files. In a Bash Unix type environment, whether it be BSD or Unix or anything, there's a convention that any files that begin with dots aren't displayed right away. And there's these 2 special files that are in every directory when you do a listing. You only see them if you do ls-A, and they're called dot and double dot. And what I'm going to do for you here is I'm going to do a long listing so you can see what's going on, okay? This dot and this double dot, here, we'll put in a capital F. Can you see how those are directories? Dot and double dot, they're directories. They're special directories. The dot represents the current directory. The double dot represents the parent directory. And so what that means is, if I was in a particular directory and I change to the dot directory, I'm still in exactly the same directory. Well, that's a little bit boring. The more interesting thing is if I change to the parent directory, I go up one directory in the directory tree. PWD, I'm no longer in PDB, I'm now in data, right? So we can use this idea of double dot, the parent directory, to go up the tree. Now I'm in J Monroe data shell. Now I'm in home J Monroe. Incidentally, the prompt is actually showing you your path. It's how I've configured it for these machines. You can change your path to be whatever you want, and it's showing you that information. But even at this level, where we've got, so I'm just doing an ls-alf, I've got these two directories, a data shell, an administration thing I've created for myself, a bunch of hidden files that you don't normally see, the current directory, and then the parent directory. I talked about these columns represent different information about the files. These two right here represent who owns the file. Double dot, the parent of your working directory, of your home directory, is owned by somebody called root. Root is a special user on any Linux or Unix machine, and it represents the system itself. It's files that are owned by the computer as opposed to a user of the system. But what this means is I can go into its parent directory and I can do a listing. And what I see is everybody else's files in the system. So here's all the other users who are on the computer. And if I do a listing that's long, I can see that these directories are owned by everybody in the class. Now, they have certain permissions, and one of the permissions is I don't think I can just go into someone else's. Oh, look at that. It's actually open. I've set it up so that you can just go in, you can take a look at someone else's files. So if you really want to go in and look at my files, I think you can. They're all the same on this machine. One directory further up again, now you're in what's called the root directory of the system. And if you do a PWD, you see that the directory is just /. That's like the top of a tree of a whole bunch of files. And again, we can do an ls, and we can, ls-f. These are all the directories that are in the system, okay? Linux machines have a standard sort of way of organizing them. Typically, you're concerned with your home directory. That is how to get back into home, right? Now, the thing is about these directories is we can actually make more than one jump at a time. If I'm out here in the topmost directory and I say /home/J Monroe, I could jump two directories in one call. In fact, I can go into data shell, data, PDB. I can type in a longer path and jump directly to that directory in one command. You don't need to put a directory on here. You can actually put any path on it. The convention in these POSIX shells is paths are separated by /. So anytime you see a /, that separates out directories all the way through. And so the idea here is you can go up and down the tree. Now here's something sort of cool. See in this directory, you can see that there are 1, 2, 3 subdirectories of data. And one of the subdirectories is elements. One of the subdirectories is PDB. If I go into PDB, okay, I'm in the PDB directory, I can change to the parent directory. And then from the parent directory, I can go down into the elements directory. And so basically I've gone to a sibling directory. I've gone up the chain and down the chain, and I can now be in this other directory. Working your way around a file system is one of the skills that you need to be able to do. You need to be able to think about abstractly where you happen to be in a file system, okay? Now, this idea of playing around, and my hope is what you're doing is you're also exploring some things. I want you to spend a moment just exploring ls, just exploring the idea of listing the files, practicing CD, taking a look at what's going on. But to give you some ideas on what to try, you can explore what these options do. And so here are some that I want you to explore, and I'll just put down in the flags to explore. Okay. Oh, I'm going to edit that again because I want to put a bit more. Edit message. I think it's. Yeah, I'm going to do one more here. Edit message. Yeah, there you go. So I've given you in Slack a few ideas of what to try. Just play around for a moment. Just go through the directories and try those different commands and try and figure out what those different flags are doing. Incidentally, there is a useful flag. I think it's just -help that will give you all of the options so you can learn what it does and you can look these things up. This idea of documentation is built into things, but that's -help. Here, I'll add that to the list so you can take a look at what's going on. Edit message. There's another one in terms of options. Okay, so there is sort of a first go. So let's just spend a moment here about browsing what these things do. And what I'm looking for is, are you all comfortable with the idea of PWD, CD, and LS in terms of going through a file system? And so for some of you, this might be like, yeah, I've been doing that for 12 years. Others, this could be new. So I'm just trying to get to the point of, I got this, we can move on. So what I will do is ask it this way. So I'll just give you a little poll. And this is a good way of making sure that no one wants to spend more time. Okay, fantastic. There was one that came in. There's one person in here that isn't quite as comfortable as everybody else. I don't mean to push you. I just know the balance in the class. I don't know who this one person is. I think it's anonymous. Are there any questions about changing directories, ls, pwd? Here, I'll give you command so far. L P. Oh, use try command. No problem at all. ls, pwd, cd. Okay, so this is what we've sort of covered. Okay, great. No problem at all. Okay, so let's go to the next sort of unit. So you're on a file system. You want to explore things. Great. Now let's take a look at modifying this. Remember, if we're at any time, if you just want to like get your screen back together, there's a command called clear that just sort of erases everything. Sometimes you just want to make things all pretty looking. Edit message, clear. Let's keep on adding it to this sort of list. Okay, new directories. Let's say you have begun to work on a pretty important document. Maybe you're doing a PhD or a master's thesis. So if you want to create new directories, then what we do is we use a command called thesis. Make directory thesis. mkdir stands for make directory. And if we do the listing, we see we've created a new directory. So now we've added a new directory to my listing of them. Turns out make directory can be a little bit more powerful than that. Say that you wanted to do not just a thesis, but you really wanted to create chapter 1, section 1, subsection 1. The -p flag will create all of the directories needed for that entire path. What it really is saying is make sure that this directory exists and all of its parent directory exists. So if I go into thesis and do an ls, there's chatter 1. Well, that's a problem. Now it's a good time to learn about renaming. Sometimes you make mistakes and you want to call one file something else. When we rename things, there isn't a rename function, there is a move function. So what I can do is I can move one directory to another directory, and what that does is it relabels it. Okay, there we go. So make directories for creating directories. Moving is how you rename things, going back and forth. Now you can see the whole structure. So if we did a ls of thesis, you can see the whole structure. Here's another switch to see the recursive all the directories in one go. Oh, okay, Omid, you had a question. Permission denied. Okay, so here is an example. Do you remember what I said about when you're doing an error message? Show me exactly what you typed in. So I'm gonna pick on you, Omid, here. You gave me a great comment in the Slack saying make permission denied. What is the full block of stuff that you typed in? What did you type in? What did you see? Nope, that's not the full thing. I want to see everything. Okay, and I'll give you an example. When I typed in make dir thesis, okay, I want to see, yeah, but I want to see this. This piece of information is what I'm interested in. Because it's your current directory, which is the important bit. So Omid, what's the whole error message? Like the, okay, so what's the prompt though? Okay, this is actually sharing useful information to somebody. So what's your prompt? Oh, it's not exactly that. That's precisely what the problem is. I'm trying to get Omid to understand that. but you're right. Thank you. That's exactly the issue. Right. So Omid, what directory are you currently in? Right. Okay. So that's the prompt. This is good. Okay. And again, you can turn on your mic if this is more helpful, but this is fine. What directory are you in right now? And you could figure that out, remember, by typing in pwd. So what directory are you in, Amit? The root directory. Okay. And you remember how we learned about permissions? So here is the root directory. The dot represents the current directory. The current directory is owned by root. You're not root. You're not allowed to modify files in that directory. That's why you're getting that error. So you're not allowed to change files that you don't own. Because you don't own the root directory, you can't create subdirectories in it. So how do I get around that? Well, you got to get back to your home directory. So in your case, it would be /home whatever. Yeah, you just type that in. This is so common that there's actually a short form for getting back to your home directory. One is cd tilde. That's the character which is below the escape. That represents your home directory. And in fact, getting back to your home directory is so common that if you just type in cd all by itself, that's what happens. So if you're in some weird directory of the system and you're far away from where you want to be, right? And you're like, I just need to go back home, cd home. cd by itself will always go back to the home directory. Okay. Thanks very much. That was a teachable moment. I appreciate that. A couple small details about working in the shell. Do you see how I labeled this file _1? While you're allowed to use spaces, we generally don't. Use hyphens or underscores. Spaces make things tricky. Try and only use dots, dashes, hyphens, numbers, and letters in file names. You can create a file name with any sort of symbol, but it leads to problems. No semicolons, no commas in your file names. That makes life really, really bad. Okay. Okay, so now we got the idea of directories. Let's imagine that I want to start working on this document. I want to start working on my thesis. Okay, so I'm in the thesis directory. Let's go to, I don't remember what the files are called, ls chapter _1, ls cd section 1, cd subsection 1. Okay, there's no files in there. How do I go about creating a file? So now we're going to talk about something called editors. If a shell is a program that lets you interact with the computer, an editor is a piece of software that lets you create content in a file. There are lots of editors out there. One of the things you need to be able to understand is how various editors work. The bare bones, simplest editor that everyone will have access to is something called Nano. So if you type in Nano and you type in something like draft, because you're going to write up a draft of a thesis, you're going to get a window that looks like this. At the top, it says draft.txt, name of the file, name of the program. It's new Nano. That's what it is. And here's the commands. Remember, this is text-based. There's no mouse. There's no menus. There's no drop-downs. Everything happens with the keyboard. And so what that means is you can just start typing. This is my great thesis, the end. And well, how do I get out of here? Well, these codes on the bottom are telling you how to do it. Well, how do I save my work, right? This is sort of an old school philosophy. It's not like Google Docs where it auto saves. You actually have to save your file. So how do you save your file? You Control O to write out. So control key on your keyboard, you hold that down, you press the letter O, and then you save it. Now, you have a lot of options. You can save it in Mac format or DOS format or do something else. We're just going to hit enter, and it will save it on top of draft.txt. And it's telling you what it did. It wrote 3 lines to the computer system. Now, if you want to keep on working, you can do some more, right? Right? And then we can save it. Control O, and then return if I want to save it to that file. And then I'm all done. How do I get out of here? You type in exit. Okay, Control X, and you're back to the command line. Okay. Now what we can do is we can take a look at the file we created. There's a file called draft. It is 50 bytes big, and it was created today. And this computer happens to actually be in Vancouver. No, that's not Vancouver. What time would it be? Is that UTC time? Yeah, this must be UTC. It must have the time zone of London for this computer. But I created it. That's one way of creating files. Now, this idea of editing it, Nano is an example of an editor. It is not the only editor that's out there. One of the things that you should do is find an editor you like to work with, right? So Nano is an editor. It's probably around. There are others. I don't know what I've installed on this computer, but I've heard of Jed. I've heard of Kate as other editors that can be installed. You may have heard of this particular one in your life. VI draft.txt. Now this one is a bit weird, so watch me before you click enter. But I'm going to do it. Here is your file. Notice the lack of anything that says Control O, Control X. There's no way to talk to it. VI comes from a world where screen real estate was really important. There is no menus. What it uses is it's called a modal editor. So you actually use the letters on the keyboard to communicate with it. So to quit out of a VI instance, you actually hit the colon and then you hit Q to get out of it. And at which point you may be going, what? So if nothing else, one of the skills you should know is how do I get out of VI if I ever end up in it. If you want to start typing, it won't work, or if it does work, it's really bizarre. You actually have to say, I want to start typing in VI. You hit the I key to go into insert mode. Now you can type and hit escape to get out of that mode. Okay. If you're interested, that's great. VI is a wonderful editor. I love to use it. But here's the little piece of information you want to write down somewhere. How do I get out of VI if I'm ever into it? You hit the escape key, colon, Q, exclamation mark. That is the way of getting out of VI if you're ever stuck in it. Get out of VI if stuck. And so I'll just put the escape key and then colon, Q, question mark. There we go. We'll put that in there. So that's an editor. I've been using VI for 20. No, hold on. When was 1994? A long time ago, right? 25 years I've been using VI. So I've got a lot of muscle memory. A lot of things are built in. Oh, yes. So Arnab, your question about it works somehow, that's because you hadn't edited it. The exclamation mark says get out no matter what. Colon Q just says quit. It will give you an error message if you modified it. Anyways, other people love another kind of editor called Emacs. Now, I haven't installed Emacs. I don't tend to use it. Here's what I'd like you to do. I'd like you to play around with some editors so that you find one that you're like, okay, this is not so bad. As I said, I'll give you a list of editors to play around with. List of editor. Okay, I'll find a list. Awesome text editors. Collection. There are a bazillion of these text editors that are out there, and I want to make sure that you're aware of one and one that you can use. I'm just trying to find a wait. And almost none of them are coming up. Terminal text editors. Oh, okay, let's just find. Here. There's a Medium article talking about what I'm talking about. That the fact that there are a number of editors that are out there. I'd like you to play around in VI, find a tutorial in VI, spend 5 minutes with it, go, hey, that's cool, I love it. Or, dear Lord, I am never going to touch this again. Play around with them so you know how to use this. Now, when I'm talking about text editors, I don't mean an application. I don't mean something like Notepad++ or VS Code or Atom. What I mean is interacting with something that you can do within a terminal. We need other editors as well, but when you're dealing with a remote connection, you need to be able to edit a file online. Okay, again, Jinyao, you keep on using the Zoom chat. Throw it on Slack so I can see that. I input the wrong name of Nano. How can I get out? Well, so if I take Nano draft txt, you mean like you typed in the wrong name here? Well, Control C for cancel, Control X to get out, right? Incidentally, this and this and this, I don't know which ways of doing it, all mean the same thing. They're all different ways of typing in Control C. They all mean hold down the Control key and do it. I don't know what unbound key M dash exclamation mark has to do with anything. So I'm responding to a comment that Jinyao sent to me in a Zoom message, and it's got to appear on Slack for us to be able to resolve it. Anyways, so please take a look at some editors. There are many, many out there. Find one you like. Find one that you're like, I can use this if I had to. Nano is fine. I find Nano to be really frustrating beyond the really simple stuff, but lots of people use it. Give Emacs and VI a try. Try something like Kate or Jed or whatever. Here, I'll play around with them at some point over the next few days to explore what's out there. Okay, while we're talking about editors, there's another way of creating a file. One way is to use a program like an editor to create a file. You actually could just create a file that has nothing in it right away. So if you were to type in something like readme.txt, okay, touch readme.txt. Sorry, maybe it's helpful if I do that. Maybe that's more readable. I'm not sure. What that does is it creates a file that has no bytes. So touch is a program that just creates an empty file. There are a number of reasons you may want to do this, but it's just a command that you should be aware of that allows you to create files. It's equivalent to opening up your favorite editor. Oh, quitting, and then you, actually that file has one character. It has the enter. It has an end of line, end of file. It has an end of file in there. Not worry about that. Anyways, it's how you create files. Touch is a way of creating an empty file that can then be edited, and you can put stuff in it. Readme, Control L, return, Control X, return, and we can add stuff to it. Okay, what else can we talk about? We can talk about dealing with files. We've already talked about renaming folders. You can rename files as well. I could rename readme.txt. So what this has done, whoa, that's looking really weird. I can rename readme.txt to readme.txt. That's allowed. And you'll see in the files now that I've got a capital R. So move is for readmeing. Readmes also lets you move files from one directory to another. So if I move this readme to the parent directory, okay, what this is doing is moving the file to the parent directory. And you'll see that now it's no longer in this directory. Okay, and then if I do an ls, readme is now here in this section 1 subdirectory. So move is how you move files around. We talked about creating files. We talked about moving files. That's me copy and pasting. The last one is removing files. To remove files, what you do is you just say rm.txt. Now here is something, before I hit X, you have to understand. Shells are designed for expert users. They're designed for people who know what they're doing. They're designed for when keystrokes were at a minimum. They're designed for efficiency. So the one thing that a computer does not do when you say delete things is ask you, do you really want to delete this? That's an add-on. So if you ever had a file which was, say, okay, I'll do this, really, I know. Okay, imagine, just for the sake of argument, you had this file, and inside was your password to your Bitcoin wallet. Okay, so there we go. Inside this file had your password. Okay, and you were used to editing it with Bitcoin wallet. And you're like, okay, that's like got like $500,000 in there. If you were to do this, at this point, you would feel very, very sad. There depends how much money was in your Bitcoin wallet. You might be able to recover it, but to be honest with you, it's gone. There is nothing left. There is no, do you want to delete this, yes or no kind of questions. So be careful with what you type in on a command line. The general rule is when you type in a command like remove readme.txt. And before you hit enter, read what you have typed in and make sure it's what you really, really meant. Now, there are some saving graces. I've been talking to you about this idea of, well, let's go back into my, let's make a file. Readme.txt. I've been talking to you about these columns in ls, and I said this first one is permissions. Well, what these are is what you're allowed to do with a file. Basically, the R and the W says whether or not you can read it or whether or not you can write it. Okay, and that's useful because it can protect you from accidentally erasing a file that was really important. You can change these permissions by adding or removing writing to a file. So if I do change mod or modify the permissions -W, that removes the ability to write this file. You see there's no more W's? And what that means now is if I try and remove it, I now have a warning that's saying, hey, this is a write-protected regular file. Do you sure you want to remove it? That is really useful, and I'm going to say N for no, to sort of give you a bit of a check, a little bit of a guard to make sure that we don't want to delete it. Mega, you asked in Slack, how do we recover deleted files? Okay. One answer is you don't. But it depends on what you've lost. Okay. If you have lost something which is mission critical, okay, like your password to your Bitcoin wallet, there are ways of taking any file system and digging into it and doing file recovery. If it's on your own computer, there's software you might have access to. You might be able to recover it. But if you're on a shared machine, like the computer we're on right now, we're all working on the same computer. As soon as you delete that, there's no guarantee that someone else didn't write over that disk space. Ideally, if you delete something and it's really important, you stop using that computer. You turn it off and you go seek help. And it depends a lot on what you're talking about. Did you lose an hour of work? Type it out again. Did you lose your entire thesis in 2 years worth of work? Well, now we're going to have a conversation about backups and the importance of backups. There are ways of helping you. You could, as a matter of practice, use the -I option. And what the -I option is it, I'll just do another one, file.txt, rm-I readme, not readme, rm-I file.txt. What it does is it asks you the question, do you want to remove this file? So you could get in the habit of whenever you're removing, don't just remove the file, remove and interrogate you. Ask you, are you sure you want to remove this file? Yes. There's a flip side, which is if you want to delete a lot of files that are write protected, sometimes you just really want to delete it. So if -I asks you, are you sure? -F says, force it. I don't care if it's readable, deletable or not. I force you to delete your file. And it will unceremoniously delete what the file is. There's one other variation on this, is sometimes you have not only, so here's this thesis, right? And you know that inside subsection 1, I have some files. If I wanted to delete this directory, you don't remove a directory, okay? Removing a directory says that's a directory. That's not what you use. You remember how we made a directory? We make a directory with subsection 1. What you're going to do is you're going to remove a directory, subsection 1. And by default, removing directories will check if the directory is not yet empty. So if you get something like this, one way around it is to go into the directory and remove the files. And then once you've removed all the files, you're done. This can be very wordy if I want to delete a lot of files. So there is a concept of removing recursively a directory tree. So that will remove this directory and all of the directories and files that are beneath it. And you can do this recursively, okay? So let's say that I wanted to just blow away my entire thesis, right? So I'm in my home directory. I could remove recursively my thesis. And this will just go and delete my thesis and all of its directories in one go. It's gone. It doesn't exist anymore. Okay. So if you were to do this, now this leads to one of those things that you are never going to be tricked by. It's sort of a joke, and you probably know where I'm going on this one. There is a sequence of commands that someone who is being mean and nasty may ask you to type in one day. Do not ever type this in. I'm going to do this very delicately and not press enter. You could remove recursively, without asking you, right, all the files in your root file system. Okay. We're not going to ever type that in, or something with an asterisk. That would blow it all away. And I'm going to very carefully backspace all that out. You have the power to erase everything on the hard drive in one command. Now, fortunately, you can't actually do this on this system because you don't have permissions, but on your own computer, you can do that kind of stuff. Anyways, so we have files, we can create them, we can move them, we can move several of them. I think the only other thing that I should talk about is be careful when using the rm command. Exactly. Here's one more idea that you may encounter. So data shell has a whole bunch of directories inside of it, right? And if you're going around, you can sort of explore the directories. You can see a bunch of things. You can see a lot of files that happen to be in it. One of the things you may want to do is you may want to make a copy of a whole bunch of data. So let's go into molecules, okay? No, not molecules. I want to go into data. There we go. So data has a bunch of files in it and a bunch of subdirectories. Let's suppose what you want to do is you want to make a backup of this data, okay? So what you want to do is you want to take all of the files that are in this directory and make a copy of it. Well, I could say I could make a directory called backup data. Now I've got two directories, data and backup data. I could go into data, and a command we haven't talked about. We've talked about moving files around. We haven't talked about copying. I could copy one of the files that's in this directory to the path backup data to make a copy of it, right? So what I've done is I've copied this file from the current directory to this parallel directory. And if I do a listing of that parallel directory, you can see that it's now inside backup directory. Turns out there are ways of copying many files at once. You can copy all of these files with what's called a wildcard. Copy all of the files that have the pattern.txt to backup data /. So what that will do is copy all of the files from the current directory, these 6, to this remote directory. Right? Now, notice how it's not asking you any questions. So just like removing files, copying is going to do it even if you didn't want to. Can you see how I copied a file and it copied the backup data? And now I copied all the files to backup data. What this did is it actually overwrote amino acids.txt. And it did it without any warnings. So if I was to take a backup.data amino acids, right, and say make a change. Oh, make a change. Okay, so I've actually changed the file. So this file has something different inside of it. And I'll show you what's inside amino acids in the current directory. It doesn't have that make a change. If I then was to copy all of the TXTs onto that directory, and we were to go again and say edit, double dot, backup data amino acids.txt, you can see how the change went away. So copy, like remove, can blow something away without you worrying about it. Okay. Here is a scenario that I actually encountered in my PhD. Okay. This was an honest to goodness recreation of what I was working on. Okay. I was working on some code, and what I did is I worked, and I remember spending the entire day on this before a group meeting where I worked on this code and I got it working. Okay, my great new results experiment for experiment 14 data 1 2 3 4 A B C D. Okay, so imagine that I had created this file, my new experiments, and this is what I had to work with, right? In terms of all of these things. Actually, you know what? Let's call this to new data, so I can get it to work, the demo to work correctly. Okay, so I've got all these files in my directory, right? I remember going, this is really important stuff. I absolutely need to remember to back this stuff up. So what I meant to type was that. But here's what I actually ended up typing. Okay. No, we'll do this a little bit better. It's not directory, so it didn't work. Move zz.data to zzData.dat. Copy sunspot. No, copy, I don't know. Sunspot data txt zz old data dot dat. We'll do it like that. So I got two dat files. Okay, so imagine I have these two files. Okay, the scenario was I wanted to back it up, and what I accidentally did is I did that. Now, what I meant to do was copying it to a backup directory, and I didn't. Question for you. What do you think has just occurred when I put in the command copy star.dat given this directory? Went to black hole? No, it did not go to a black hole. Copied everything with the dat extension? No, it did not do that. Let me show you what it did. Now I want you to look at two things. One is the size of this and the size of this. So I had two files, z new data, z old data, one which was small, one which was big. You see the size of that file and you see the size of that file? So what I did by typing in this command is the star said, okay, well, what are all the files? Oh, and it goes, okay, zz new data, zz old data. I can expand that. I will turn this expression into copy new data space old data. And so what it did the equivalent of is it very helpfully did that command to me. It said, oh, you want to take the content of this file and overwrite the content of this file. I didn't accidentally remove something, but for all intents and purposes, that file is now gone. And as I said, I'm speaking from experience because my day of work was gone. It can happen. Now, these are the things about command lines. They do exactly what they ask you to do, and they do it without remorse. Anyway, so just be cautious about what's going on to understand what the actual act is going to be as you're going back and forth. Okay, so we've got files, we've got directories. We'll make a list here about some new commands that you may care file related commands. Okay, we have looked about make dir, remove dir, rm, mv, cp, touch, nano. Okay, that's the list of things we've just covered. Every one of these things has additional switches. And this is how we tend to move around and do things on a command line. Okay, so the idea here is this is how you begin to navigate yourself. You need to know where you are. You need to go into a directory. You need to do some stuff. This is the ins and outs of working on the shell. Okay, so this, again, apologies if this is all very simplistic for you, but want to make sure that everyone's on the same page. Does anyone have any questions about directories or shells or permissions or moving around a file system? Anything like that we should talk about? Okay, let's do one more little block of information and then we'll take a 10-minute break because I know I've been talking for a while. I want to talk about something a little more powerful, and this is the idea of combining commands together. Okay, so what I want you to do, and you can follow along with me, is I want you to go into the molecules directory, okay, and take a look at what's in there. And you should see 6 files, okay? And what these are is the, it's something from the protein database, I think that's what it's called. It's a way of saying where all the atoms are in each one of these molecules. And again, if you open up a text editor for Octane, it's saying that, okay, in Octane, where actually are the carbons and the hydrogens in an octane, right? If you've done any like organic chemistry, you know, you get methane, octane, butane, all these different anes. They're a bunch of carbons and hydrogens. And so these are the actual atoms in their relative geometric orientation with everything else. And I've got ones for propane, pentane, methane, ethane, cubane, whatever the case may be. Okay. There are different ways we can take this information and start asking questions about it. So, for example, I could open up a text editor and say, how many lines are in this file, and count them all up, 1, 2, 3, 4, 5, 6. But counting lines in the file turns out to be a really common thing. So there is a command called word count, WC, that you can type in WC file, and it will tell you how many lines, how many words, and how many characters are in your file. It's a very common thing to do. In fact, you can do WC on whole sets of files, and this will tell you how many lines, how many words, and how many characters are in each one of these files. A word is defined as things separated by spaces. And you can see right away that octane is a much larger molecule than methane, just the number of lines, which are proportional to the number of atoms all the way through. Okay, so let's say if we took this information, we may want to look at it and do some stuff with it. Okay, again, with other commands, there's ways of simplifying this down. If you look at the documentation for WC, you'll find a -L command for lines. And what that will do is show you only the number of lines on the file, not lines, words, and characters. Okay. There are other options, -M for number of characters or -W for the number of words. The way that this is working is anything that goes over here is being read in as input. If you don't type any input in at all, it's actually going to take input from somewhere else. It's not going to take input from the file. It's going to take input from standard input, it's keyboard. And what that is if you type stuff in, it's like adding the file in. So if I just start telling a story, right? There once was a ship, I'm trying to remember the TikTok, called the something, whatever it happens to be. I'm giving it data. When I'm done this at the very end, what I can do is I can end this file and pass that information in WWC. And the way you end a file, Control C will work, but not quite the correct way. Control D will end the file. Okay, so I did a like Control D character at the end of those files, and what that did is it took the information that I was passing in. There once was a ship called the. Well, there's 7 lines. It told me 7. So these files, we either take information from standard input or from files you load on the command line. Okay, so this is an idea of taking input from something else. Okay, there's a third way of getting information to a file. You can either read it in from a bunch of directories, or you can get it in from standard input. A third way of doing it is you can read that information in through what's called a pipe. Okay, so if I was to take, say, all the files that are in my directory, so ls, right? You see there is 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. If I wanted to count how many files are in my directory, well, what I could do is I could do an ls, and I could take the output from that and pipe that to wc-l. So this is a long listing of files, and I'm counting how many lines are in there and passing that off to wc. And so it's counting 1, 2, 3, 4, 5, 6, and there's the 24. If I got rid of the long listing, there's the 6. So ls by itself is producing a list of items. Okay, 1, 2, 3, 4, 5, 6. And what wc-l is doing with this pipe is taking the output from that command and using that as the input to the next command. This is called piping. It's equivalent to when we went just wc-l and just sort of waited and had us type in things, 1, 2, 3, 4, 5, Control D, and it gave you the answer. When I use a pipe, I'm taking the output from a command and piping that information into another command. So this idea of piping means take stuff from one file to another. Okay. There's another thing we can do in terms of directing input and output. Just 1 second, please, for a moment. Nope, not that one. Where is share screen? Go to share. Something was distracting me, and I just lost where I am and what I'm doing. I have no idea where I am. I'll have to wing it. Windows, you all closed on me. Why did they all close? It's not you guys, it's me. Pipes and filters. Okay, there's one other things we can do, which is taking the output of a file in the same way that standard input controls what comes into a file. What I can do is take the output of the file and pass that into something else. I can either pass it to a program, or I could direct it into a file. So this is called a redirection, this symbol right here. It takes whatever this thing would normally spit out to the screen and put it into a file. So now if you take a look at what's there, there is now a links.txt, and I can open this up in an editor, and I can see the output from that command again. Now, going and taking a look at what's inside of a file is such a common operation that there are actually programs that do that for us without having to open it up in an editor. You don't always have to use Nano to open up a file to see what's inside of it. If you just want to see what's inside of it, there's a command called cat. And what cat does is it just takes whatever was in the file and it spits it to standard out. It spits it to wherever you're directing information. So what cat does is it takes the content of this file and spits it to the screen. The trick here is now what you can do is you can take the output of that and you can actually pass that to something else. So I could take this data, this stuff, and rather than spitting it to the screen, I could pipe it to another program, like the program sort. And what sort will do with a -n is sort data that has numbers in the front. So you can see what I've done is I've taken that length of data and sorted it out. So now the files are sorted by their length, telling me right away that methane is shorter than octane, which you probably knew, but it's a way of looking at this data. In fact, what I could do is I could bypass that. I could take all of the files that are in here and just pipe that directly to sort.n. So you're taking the output from this command and sending it off to be the input of that command all the way through. This idea of chaining files together with either direct redirections to files or with piping is key to how this all works within the shell. This is how the shell becomes a very powerful thing. You've got a number of specific commands that do one thing and do it very, very well, and you could chain them together all the way through. Incidentally, this is if cat tells you something and takes the contents of a file and just spits out to the screen, sometimes you just want to take some phrase and spit it out to the screen. That command is echo. If you just echo something, whatever you type will be just spit out to the screen. My fave color is blue. Okay. All this program does, echo, is spit something to the screen. We use it by linking it with other programs. So if I take that phrase and then pipe that to a file, nothing appears on the screen, but now my fave color is blue appears on the screen. If I was to take this line and do it again, you'll see that what's now in test file has been replaced all the way through. So this redirection takes whatever the output is from a command and replaces the output, replaces the content. There is one more thing you should know about, which is the double arrows, which appends. And what that does is it takes a file, and if it already exists, it adds to it. So now what's inside of it are two lines all the way through. Okay, let me give you an exercise here to put these things together for you to play with. Okay, so let's go up a directory. Let's go into data. Okay, so here is, okay, I'm going to get rid of my ZZ files for a moment. Here are some datas. Okay, so there is animals.txt. Okay, and what I want to do with this data is I want to play with it. Okay, so I'm going to figure out a way of taking this data and well, it's not even that much data. Sunspot. Oh, this is a good data set. Sunspot data. Okay. Let's take let's do this one. Let's do Sunspot. Okay. So here is some data. You saw it went on for quite a while. There's a lot of lines in this file. Okay. So there are 3,080 lines. Here is an example of what we may want to do with chaining these tools together. Suppose what you needed to do was you need to take these files and you only wanted the last 4 lines of the file and the first 4 lines of the file, because you just wanted to see what this file was, but you didn't want to see all of it, okay? Because when I do a cat of sunspots, there's lots of stuff. What is a way I could create a sequence of commands so that I could get another file that has only a subset of all these sunspots, specifically the first 4 lines of the file and the last 4 lines of the file? And here's what I'm going to give you as a command. And exactly right, Omid. There is a program called head, which takes an argument, the number of lines, and I can pass in sunspots, and it gives me back out the first 4 lines. And there is a program called tail, which gives me back the last 4 lines. So here is my challenge to you, is I want you to figure out a sequence of commands so that you have a file that is called sunspots.subset, where it has the first, let's say the first 8 lines of sunspot.txt and the last 4 lines of sunspot.txt in one file. Okay, so I'm not sure if that's clear or not. Let me, I'll just write it out. Create a new file, sunspots-subset, that contains the first 8 lines of sunspots.t followed by the last 4 lines of sunspots.txt. Okay, yeah, and I'll give a note on that one. We'll make this interactive, edit message, use head, tail, and redirection. There. In Slack, I've given you a little scenario, right? Something that you may want to do. So what I'm looking for is, okay, I got this file. I want a new file. It's only got a certain number of lines. Give it a shot. It's just, do these ideas make sense? And if they do or they don't, we'll try something else. You cannot find the sunspot. Here. Does that help if I give you the path? Okay, you'll see that on Slack. What I've done is I've just created a little thread. Once you got this worked out, you can just go and tell me, this is how I would have done it. Okay, so Brad has a solution. And just because Brad has a solution doesn't mean that that's the right solution. Okay. And again, if you're just feeling like, I don't know what's going on, turn on that mic and just talk through it. Okay, so I'm not seeing any feedback. Thanks, Brad. I appreciate the answer, but that's only one of you. What else we got? Okay. So a couple things. I appreciate some answers in the Slack. So we talked about using threads. Threads in Slack is a way of keeping this organized. So you can see how I gave you a question, create a new file, and then I started a thread. That's a way of putting the answer in there. And it's not the output. We don't really care what the output is. What we care about is the commands you typed in to make the output, right? So yeah, because it's not so much what you got, it's how you got it. So I'm just waiting for a few people to give me some things here. Okay. So just to walk through it again. Right. Okay. So Emmanuel, I like what you put down there. That's what we're getting at. We're getting closer. We're getting closer. So just some comments, right? So the first one, I'm going to take up Brad's solution for a second. I see that it's a capital H head and a capital T tail. I'm sure you didn't do that on purpose. I'm sure Slack just made that capitalized for itself. When you're typing in code in Slack, put things in code blocks. So when it says reply, and then beneath the reply, it's got a capital B for bold and a /I for italics and strike through. At the far right, there is a little icon called code block, and it lets you actually put in code that will be formatted like code. And when you're typing in a command line, it's sort of like code. So put your stuff in code blocks so it gets formatted correctly. You always can go back and edit one of your messages again. So Emmanuel, you gave us two outputs. You could have just put them both in the same block. And if you're trying to figure out, well, how do I type more than one thing in? Shift enter in Slack lets you go to a new line without doing it. The other comment I'll have about this thing is the instruction said create a new file sunspots-subset.txt, and the two solutions I'm seeing in the thread, one person put the file into subset.txt, the other one put it to task1.txt. I know, totally immaterial what you call the file, but generally, when you're working with computers, if the instructions are put the information into a file with this name, you got to put the file into something with that name. That's pretty key in terms of how the software is designed to be used. So yeah, okay. So we got a few different things on there. So that's just an example of how to chain these things together. Let me give you one other variation on the theme to sort of get the idea. Okay, so let's go back to this directory of data shell/data, and specifically, let's take a look at what's in animals.txt. Okay, this is a command which produces some output, right? So what you can do is you can take that or this file has some columns in it. Let's say what I wanted to do was I wanted to figure out how many deer, how many rabbits, how many raccoons did I observe, right? This might be for some study where you did observations of different animals sawn on different dates. What we can do is I can figure out what's inside the command. And I'm going to give you just a few things to work with it. The first thing is I'm going to give you a new command which takes a file and then can split it up and process it so that you're grabbing a particular column of this data. And that command is cut. So what cut does is it says, okay, treat this file, use a comma as a delimiter, something that separates the columns, and give me the second field out of all of those commands all the way together and split it out. So cut is a very useful tool for slicing and dicing data which has lines in it. Now, with that command, I'm going to ask you another question. And I'll just put it again in Slack. Why? I need more screens. I don't have more screens, but I should get more. Okay. New task. Okay, so here's the new task here. I'll just try and do this in a nice sort of way. Okay, so again, I will just suggest that. So I've just give you another task in Slack. Right, go ahead and give me your best 1, 2, 3, 4, or 5. So the task here is you got a file. It's got some data into it. You're going to take the file and you're going to process it some way and try and figure out how many of each animal there are in this list. Now we can count them. There are 2 deer and 3 rabbits and 1 fox and 1 raccoon. But which one of these commands I've given you in Slack would, in one command, just count them? And this is the idea of chaining commands together. So go ahead and play around with these things and see what they do. And we can talk about that in a minute. Okay. And again, Mega, what you've done by saying 4th option is just fine, but I'm trying to encourage you to use Slack and keep things organized. So try and reply to questions in threads. You're totally right. No problem. This is just trying to figure out a way of the 20 of us sort of working together. Not a worry at all. Ah, we have a disagreement. I love it. So there's only 2. Well, there's been 2 number 4s and 1 number 5. 3 number 4s. Okay. Oh, he's back to 4. Okay. So I think those who are doing it are understanding. So what these are is a sequence of commands that are doing certain things, right? And they all produce different output. But what you'd want if you wanted to count the number of words, deer, rabbit, raccoon, whatever, you first want to select out that column of information. That's with the cut -D, comma, -F2. Pipe that to sort, right? And then type unique. Now, I got a question for you, though. Why couldn't we just do number 3? Why is it necessary to sort before looking for the number of unique counts? Why doesn't number 3 work? And you can explore that because I can tell you what like unique C does. Unique C is a command, right? You just like any other command, you can just type right on it. So I can just give it some data. Exactly. Consecutive lines. So you see what I just typed in there? The way unique works is it looks at the line and says, okay, is it the same as the last one? Is it the same as the last one? Is it the same as the last one? As soon as it changes, it goes, oh, okay, we're on something new. I've counted 5 ones. Oh, you gave me something new. I've counted 1, 2, 3, 3, 3, 3, 3, 3. Oh, I've counted 6 threes. 4, 4, 4, 4. I've counted 7 fours, right? So by sorting them, what we do is we first group together all the deers and all the rabbits and all the raccoons together, so we can work through this. Okay, let me just see. So designing these kind of things is what we use this for. I'm trying to think if there's any really good exercises I got lined up. Yeah, I think you're getting the idea of pushing these things together. Okay, I want to conclude today by talking about some scripting, doing loops and bash scripts, but I know we've been doing this for a little while. So do you want like a 5-minute break or like a 10-minute break to like, biology and water and those other kind of things? 10 minutes. 10 minutes is good. Okay. Because I know you're like, Zoom time. Um, this would be a lot easier in person, but we do what we can do. So great. It's 10 minutes. So at 3:30 St. John's time. If I got no 3, what time is it there? 3:20? 3:20. At 3:20 St. John's time, 40 past the hour in other time zones. 10 minutes from now, I will see you back here. You'll know that because I've turned my video back on. Anyways, take a break, go find something. See you in a moment. Well, hello there. I guess we'll get started again. Hopefully my mic's still working. Hopefully we're still recording. Too many buttons. Yeah, it's all working just fine. Okay, so our last little shift here. We got 40 minutes before the end of this sort of session, which point will all disappear. I wanted to tackle doing slightly more advanced things. Now we got the basic idea of we type in commands and either files get produced or outputs get put to the screen. How do I deal with all this stuff? What useful work can I do with these tasks? And so I'm going to talk about looping as my next thing. So if you're familiar with programming in any language, you know that a loop is a fundamental construct. That's something you want to do something again and again. If you are new to programming at all in any language, loops are about performing the same action again and again and again. Okay, so let's say how can I do this? Well, let's do the following here. Okay, so let's say that I am in what directory? Yeah, here we go. So let's hang out in datashell.creatures for a moment here. So here are some files. Okay, they all have a fair number of bytes, right? We can take a quick look at one of them, right? And what you're seeing here is a bunch of genetic data. Okay, this is the genetic data supposedly from a basilisk. I don't think this is actually the genetic data from a basilisk, but let's suppose that it is. Okay, so I've got some files. If I just cat the entire file, it's a lot of stuff going along here. I really want to see it. I really just want to see the first few lines up here. I want to sort of see this header information for a bunch of lines. So one thing I could do is I could do head-n5 and type in basilisk and minotaur and unicorn, and I could get the output of the first few lines of that file, and that file. Okay. Often when we're programming, we want to do something on a list of files. So let's just say that what I wanted to do was for each one of these files, this one, and this one, what I wanted to get out was this part of it, just this sentence. I wanted the classification of each one of the files, each one of these three mythical animals, 1, 2, and 3. So what I could do is I could figure out the code I needed to take a file and extract out just this one line. Well, so the way you do this is you build up what you want to do. So what we want to do is we want to take a file and we want to extract out a single line from it. And one of the tricks in doing that is you can take a file, say, look at the first 2 lines of a file, okay, and then take the output from this and look at the last line of the output. And you can see that what this command does is it takes a file, and then for that file, it spits out just one line from it. It takes the top 2 lines, and then from the top 2 lines, it takes the second of those 2 lines and spits it out. So what I want to do now is I want to run that line for the basilisk, for the minotaur, and then for the thing. Obviously, copying and pasting this line is going to be a problem. I don't have the ability to do anything like this. Okay, if I tried to do something like that, that doesn't work as a program. What that will do is take all of the files and only get me the last one. What I want to do is I want to do this command where this thing changes every time. And this is where a loop comes in. So the way that loops work in shell scripting in Bash is what you do is you have the word for, and then you got some variable that you're going to use to represent what's going to change in it. So let's say for file name, now you give it a list of things. So the list could be a basilisk.dat and a minotaur.dat and a unicorn.dat. hopefully I spelt those three things right. Bacillus, Minotaur, Unicorn. So those are the three things. And what you do is you say 4, and then Bash knows that this is not the end of the statement, okay? And so what it's done is it switched from the $ prompt to the angle prompt, saying, okay, for this name is going to take on the value of this phrase, and this phrase. What do you want me to do? Well, what you want to do is do something. What do you want to do? You want to take the first 2 lines from this file, and in Bash, what it is to make sure something's represented as a variable, you put a $ in front of it. And so you say, what I want you to do is take the first 2 lines from the first file, and then from that, take the last 2 lines, and that's all I want you to do. Then you're done. Okay, so what this has done is it's taken 3 files and done something to each one of them. And so you could imagine this if there was not 3 files, but 300 files, to go in and grab the second line of 300 files is something that you could do with an editor or with Microsoft Office or Notepad. But using a line like this, not even a whole program, just quickly getting it all done in one go. Okay. And in fact, we can be even a bit more brief. I don't need to say the word file name. I could just say for X in that list of files, right? Do head-n to X tail-n-1 done, right? So I can call this variable whatever I like. And you can actually group these things together. So I could go for X in all, I think this is going to work, for all of the data files, do, what do I want to do? I want to do this command head-n to $X, and then take it off, and then do a 1, and then done, right? So you can make these more and more compressed as you want to do it. Now, so you can use wildcard, select things. This will make a list of all the files it can find of that pattern, and then do that operation on each one of them all the way through. Okay. Let's say I'm just trying to do some other variation on a theme here. This is a file. That's sort of boring. That's boring. Okay, how about this one? Let's go to the molecule subdirectory. Okay, and inside here, we've talked about this before. There are a number of PDB files. Okay, so I'm going to give you some code. So they're all alkanes. So I'll say for alkanes in each one of these PDB files, do what I want to do. I want to echo maybe the name of the file so that I can sort of see what's going on. And then I want to catalog or take, I don't know what I want to do. I want to, yeah, I want to cat the alkane file to all.pdb, and then I can say done. Okay, so here's my question to you, and you could just do this yourself to discover it. What will be the end result of running this program, this little program, right? It's saying for alkanes in star.pdb. Okay, so you're going to loop through all of them. Do, okay, what do I want to do? I want to spit something to the screen, and then, well, run it for yourself. Oh, now this is tricky. That didn't work. Mistake in names. Aha! Aha! Thank you. Very, very good. right? Because I can't in blank, so it was actually waiting for me to say it on the screen for it to work. Okay, so I'll remove. Yeah, awesome. See, typing's hard. Incidentally, when you're typing things in, you can say for, hit for return. If you want to, you can just type it all in one line and use semicolons to separate out the statements. So this is a valid piece of bash scripting. For alkynes in star dot $ do echo this thing, command done, right? That's another way of doing it all the way through. So it's a way of grouping all that information together. Let's do something slightly more interesting, right? Okay, so this star, this thing is appending. So if I was to run that command again, right? Okay, there's sort of a bit of a mistake here. You see that it's picking up all.pdb. It's picking up that first file in that list, and it's going to be adding the contents of it again and again and again. So as I run this file, all.pdb is going to keep on getting bigger and bigger and bigger. So if I was to modify this program, what I probably would do is first remove all.pdb, then do the loop, then do the echo, then be done. And now that becomes a reproducible line we can have happen again and again and again. Okay, let's try something else. Let's say we wanted to just trying to find. I got a whole bunch of examples. I'm just trying to pick one that would do something that you may. Okay, so let me go over to the creatures directory. Okay, here is another variation on the theme. Let's say that I wanted to look through all the files that are .dats, and I want to do what I want to do. I want to echo the file name just so that I can see how it's producing, and then I could say, give me the first 100 lines of the file name and the tail, the last 20 of it, right? So what is this doing? It's going through, printing out the name of the file, giving me 20 lines after 100 lines of the file and the data, and then spitting out the next line as a way of viewing the data all the way through. So the idea is loops, right? So we have loops going all the way through. I'm just trying to find. Oh. Okay, I got one more for you, and this is probably more useful. Let's take a look at the North Pacific Gyre. Okay, and imagine someone was doing a research task where they had a bunch of files. Okay, and for each one of these files, there's a lot of them. What you needed to do was do some analysis about them. Maybe you needed to make a file which had some operation on it. You needed to, for each one of these files, calculate some statistics on them. Let's take a look at one of these files. So NE 1729, I think it's buoy data, right? It's just a bunch of numbers, okay? And you can imagine that each one of these files, you needed to load in and do some calculation on them, okay? Well, there's a program in this directory called goostats, and what goostats does is it takes in a piece of data, okay, and what you do is you give it as output the name of the file that you want it to be, NENE01729A.txt. Okay. I think that's how it works. Yeah. So what this program does, whatever goostats does, like global ocean observing, I think is what goo means, is it does some processing on this file and it produces this file. Okay. So I think this is like the mean, the mode, I don't know what it is. It's just some calculation. Okay, so the idea is we imagine this is some program which takes this as input and this is output, and it calculates statistics on each one. So here's our challenge. What we want to do is we want to write a program so that for every file in this list, what we're able to do is call this line, so at the end of the day, we have a whole bunch of stats files and a whole bunch of input files all in one go. So we don't have to type those lines in again and again and again. Okay, so we can do this sort of a little bit collectively. Let's try and use our ability to write loops to do that operation. So do a loop where it calls a command like this for every file that happens to be in there, and see if you can process all the data in this file in one bash command. Does that make sense? I hope it does. I'll make up a new thread and we can get this started. Okay. For every data file in wherever we are, run okay, so there we go. I will give you that as the challenge, and I'm fine if you want to work on this as a large group, or you could just do it by yourself. Try and figure out a way of using a loop to process this data. Yeah, that's a good way of asking how to do these things. Yeah, okay, so we got some data, great. And I'm just going to pause for either someone to reply to the thread or just turn on your mic and talk to me about what problems you encounter, or none at all. I don't know. It said, because I can't see anyone's cameras on. I don't know who's working and who's sitting there going, waiting. So any information in the Slack thread would be really appreciated. Arnab asked a very useful question. What happens when you're in an infinite loop? Control-C is how to break things in Bash. Okay, I just see a posting from Kabir. For X and Start-X, do touch files. That would definitely create a bunch of files. It's a good start. We can work with that. We can work with that as a starting point. Okay, Emmanuel has another variation on that. Okay, so again, I'm just following along the Slack thread, which is a great way of looking at this. So Emmanuel, I appreciate that you're now using code. Try code blocks as opposed to code, and you'll like how that looks a bit better. Code just makes a single line. Code blocks allows you to do a chunk of stuff. Okay, so what that program does is it's almost there, but not quite. Okay, so I've now seen a couple of solutions in from Slack. When you run this, are you getting what you expect as the output? Okay, in the sense of look at the files. So I'll take one of these solutions. So Arnav, you just gave me one. I will go and I will take your command as presented and I will run it. So the first thing that I notice, and this is what Omid mentioned, is it appears to hang for a while. What's a way that I could figure out whether or not my program is actually stuck or if it's just doing useful work? Yeah, you can use a print command. Okay, exactly. And in Bash, what's the way of getting something to display to the screen? It's not print. It's echo. So what we can do is we can modify it so that we loop through all the files, we echo the file name, and then we run it. And so now you can sort of get some feedback about what the program is doing, right? And this tells you right away, it's like, okay, I know I got to get to 2043. I always love to put this kind of feedback in my code. It tells me whether or not I should just sit here and wait. Should I go get a cup of coffee? Or should I go home for the day because it's not going to be done until tomorrow, right? And that kind of feedback is really useful when you're writing programs. So this is telling me like, okay, I should wait. I'm only going to get to 24.3b and I'll be done. Okay, so it's running along. It's doing all the analysis. Okay. What's going on here? I'm taking the data files and now I'm analyzing the analysis. What has happened? What's going on here? In fact, I've got a file here called stats. And if you take the LS listing, I now have my data files, my stats files, my stats files, and even a stats files. Okay, so again, here was the suggestion that we're working with. What I need to do is I need to be a little more selective about which files I need to deal with. And we haven't talked much about this, but this star does pattern matching. Star.txt matches only the files which end in a txt. You actually can be more specific than that, and you can describe a file like that. Take files that begin with NENE then whatever, followed by a .txt, and then only for those files do your analysis. Okay, so typically what we want to do is we want to write a program that selects only a certain amount of the input, does something with some visual feedback, does the work, and that becomes a whole program. So you can imagine this is something that if there wasn't 20 files, but there was 2,000 files, you could just let this run overnight as a program. So what bash scripting is often used for is controlling other programs to do something repeatedly again and again and again. Okay, so we've had a lot of variations on a theme here. We had a few different attempts, right? Here was one version. Here was another version. Here was another version, right? At further up on the top. How would I go about finding the version that I wanted? Well, there's something built into bash and other shells called history. And what history does is gives me a list of every command I've ever typed in. Okay. So what's nice about it is I can go back and I can figure out every command I had ever typed in. And I could go, well, which one is it that worked? It was this last one. And just in the same way that what history can do, what any command can do is I can go through this. I can pull out, say, only the last few lines of a file, right? And that will grab me those last few lines of that history file. And in fact, what I could then do is I could process. I could take those lines. I could put them into a file. Okay, I'm going to get rid of all the stats ones because those are silly. I could take a script file like process.sh, and I could take the history command and dump the content to it, and then open up my favorite editor, whatever you happen to like. And I could modify this so this became the program, and I could then use this program and run it again in the future. So this is often what we do is we use a combination of editing things on the command line, but also editing them in text editors so they're reproducible and we can use them again. So here is the program that we typed out. And this becomes an entire program. So you see process.sh. sh is just a common extension we use for shell scripting. What you can do is you can open up an editor. And again, this is why you need a text editor. I don't care which one. And inside are going to be all the lines of code. Because I had the extension sh, Nano is doing something very helpful. It's coloring in the words that it recognizes as being commands in the bash language or being programs it knows. And I can edit this and modify it however I want. If you want to go and then run this program, there's two things you can do. One is you can use the word bash, which is the shell we're using, and actually run that program. So what this is doing is taking the program process.sh and running the program bash. And this is how we begin to do scripting. We begin to put all these commands together so you can run them again and again. And again, Control C is how you quit out of something. Alternatively, what you can do, you see how GoDiff and GoStats are green? The reason they're green is they have had a permission bit set. See this X? This is to say, make sure this program is executable. And if it's executable, then, which is the +X option, then what you can do is just say ./process, and it will run it as a command without even typing bash at all. So sometimes you make scripts and you make them executable, and you change their permissions by making them executable and run them. But bash process is fine too. Okay, so I just want to make sure you knew how to do a loop through things or a loop through files in a directory. So you can always just have the loop be explicit, right? If you wanted to just, I don't know, count through things, right? For letter in, I don't know, A, B, C, D, do make, no, we'll do this. Touch my file $letter dot t, no, tstd8, done, right? So there was a little loop that created 1, 2, 3, 4 files. So we often do things just on the command line if they're one-offs, or if you want to put them into a shell script because they're more complicated, or you want to reuse them, you could do that as well. We've talked about loops, we've talked about scripting, we've talked about permissions. Just going through my own notes here. Is there anything else that I really wanted to share with you one way or another? Yeah, okay. So I think that's good enough for right now. Okay, and there's obviously tons more to learn in terms of it. Let me give you a few other resources that are out there that you may really appreciate knowing about. So let me just where is the share button? Share, new share. Okay, so this is just a web browser. Okay, well, first thing, and this is the link that I gave you at the top. All I'm doing is picking up some notes from this site. This is a software carpentry. It's an organization that sort of tries to teach people sufficient skills to be able to use computers for science. You're not a software engineer, you're a software carpentry, hence the name. And I've just been pulling some examples over here to guide us through. You're welcome to look at this as the documentation of what we were doing. The textbook that I linked through, I think it's like something called Computers for Physicists or some name like that. It's not really for physicists, it's for people who do computational science. It has the same information as well, that you may be interested to look at. So that link is a way of sort of going back and going through these things. We've covered introducing the shell, navigating files, working with directories, pipes and filters. Filters are things like unique and sort, loops, shell scripting. There's a little bit of stuff on finding things that you may be curious to read through. I will leave it for you to sort of browse through that. And if this is new to you, call this it. This is a great introduction to Bash. It's a lot of information. If this has all been like, yeah, I sort of knew that, I've been doing this for a while, I will point you off to this link called Shell Extras. Here are some other things that you probably want to know about that I don't require you to know about for the course, but spend a little bit of time just sort of going through it. There's a million pages of documentation out there. Here is some other things that you sometimes want to know: man pages, working remotely, more about permissions. I talked a bit about change mod, the idea of directory structures of a Unix machine. That could be of interest to flip through, but it's not strictly speaking required. But we've now done at least an introduction to the Bash shell. And the way we had set this up is I had given you access to a computer that we connected with remotely. And the way we remotely connected with it was using this command called SSH. Now, SSH stands for Secure Shell. So what we were able to do is be able to connect to that remote computer and enter these commands, and I set up some data for you. You're remotely working with a computer. If you have need of this, if you're doing something with Compute Canada, you're doing something with SSH, it is nice to know that SSH can have a lot of fun features. Like, there are ways of using SSH where you don't have to type in your password. You can create password keys. You can copy files back and forth using something called secure copy. You can set things up so that it will default to a number of things. If you're an SSH user, you may be interested in reading through this Shell Extra stuff. Link is in Slack, link is in the description in the announcements for some additional things you can do, and I'm happy to help you with any of those. Okay, where does this leave us? What do I have to do with this work? Okay, well, there's two tasks. Here's number one. Number one is sort of a mini assignment. I'll call it an assignment only because you sort of need to do it. Okay, well, wrong folder. Why is there's no content? Duplicate tab, duplicate tab, course home. I am in the wrong year. I am in the when I taught this last summer. Wrong year. That's why I can't find anything. There we go. There's us for this offering of the course. Course content. Assignment number 1. Here's my assignment number 1 for you. Okay. And I'll even copy and paste this right into Slack for those of you who want to just use Slack. Assignment 1, and then I'll do an attachment, and no, I want to create a file. Why can't I create a file? That should work. Okay, so I've dumped this into Slack. If you find it more useful to refer to there, it doesn't matter. Here's what I'd like you to do. Is I want to make sure that you have access to your own terminal, your own bash instance that's not dependent on a remote machine. Now, I've created this machine. I'll leave it up for the next few weeks. You can use it to play with. That's fine. But you really should have access to this kind of software on your local machine. Now, if you're running an OS 10 machine or a Linux machine, you're done. There's no work to do. If you're running Windows 10, at minimum, I'm going to recommend you download and try a piece of software called Windows Terminal. That's the thing that I was demonstrating before. It's a lot nicer than the PowerShell terminal. Just got better fonts, better graphics, better copy paste. And you may be interested in setting up something called Windows Subsystem for Linux. Okay, that's a way of getting Linux running inside your Windows environment. Now, that takes a little bit of going through. There's a link here to the setup instructions that walks you through doing this. And I don't seem to be able to go to that link, but okay. It's just a link under Shell Novice. Here are the 3 sections. If you're Mac OS or Linux, you're fine. If you're Windows, we suggest you use Git for Windows. I don't want you to do that. I want you, if you're a Windows user, to attempt to install the Windows subsystem for Linux. As long as you're on an updated version of Windows 10, there are some instructions here. And it does say if you are, like currently, if you are on a modern version of Windows, okay, build 20,262. And again, if you run the program winver, I know that I'm on version, you can't see it, so I'll just share the whole screen. We'll just do this really quickly. So this is what my winver, W-I-N-V-E-R, says. I'm on build 21,376. As long as you are at least at version 20,262, then just going to the PowerShell and typing in wsl-install will do it, and you're done. If you're not at least at that version, it tells me you probably should be updating Windows 10, but I get that updating operating systems is a big deal. If that doesn't work, then here is a sequence of steps you need to follow. You need to do the following things. You need to enable the Windows subsystem. This works for Windows 10 Pro, Windows 10 Home Edition. It doesn't really matter. And what it does at the end of the day is it allows you to download from the Microsoft Store a Linux distribution, several of them. I'm going to recommend Ubuntu, Ubuntu 18 or Ubuntu 20. Just get that up and running on your machine. And the reason is it's not just the shell. We're going to be using Git, visualization packages, Python, and other pieces of software that all sort of work in Windows, but you hit barriers. You hit obstacles almost right away. So my strong encouragement is to at least attempt to install a Ubuntu system locally. Windows Subsystem for Linux works really nicely for Windows users. If You already are a Linux user, you're fine. If you want to play around with a virtual machine, that's fine. But do something to try and work through it. Okay, so that's step one, is to try and get your system set up. And after you've tried it, if you're like, this is never going to work, that's why I created the remote server. And that's fine too. I just want you to try it. Here's task two. Okay. What I want you to do is I want you to go to a website called github.com. GitHub.com is something we'll talk about next time. Git is a way of doing revision control on software. If you are a computer science student, I am sure you already know what revision control is, and I'm almost sure you've got a GitHub account, but maybe you don't. In either case, sign up for one, they're free, and because you're all students, sign up for the Student Developer Pack. There's some neat bonuses and bundles that come in that are free. You may be interested. There are graphical Git clients, but we're going to try and do Git from the shell prompt. So what does that mean? It means when you've installed this, I need it so that when you are working in your machine and you type in git -- version, something pops up. Okay. If you get command not found, then you need to install Git. And there's going to be a million tutorials out there, if not going through how to download it. If you've done Windows Subsystem for Linux, it's going to come automatically. For people who are running Mac OS 10, install Git Mac OS 10 probably is the search you want in Google. You'll figure it out. I want you to make sure you've got Git installed, you've got a terminal installed, and the third ask is play with some text editors. You absolutely need a text editor that you can use from a terminal. So Nano is fine, Vim, VI, Emacs is fine. Play with one of them. I know that they are a very personal thing. See this comment for XKCD as an example. You also should explore another native editor, still a text editor, but not one that you use sort of on your system. It's a piece of software. I use VS Code, again, from a Windows point of view. That would just be new share, screen, share, right? Microsoft Store, right? Search, VS. Okay, VS Code stands for Visual Studio Code. Is what it stands for. You are looking for. I want to make sure I get the right. It's not on the Microsoft Store. Okay, then we don't install it that way. We just go to VS Code as a search. Yeah, we'll just do that. I'll drop that in Slack for an idea. Okay, these are called integrated development environments. Is what we're doing. Waiting for cache. Right, download for Windows. And the thing about VS Code, and so I'm going to encourage everybody at least to take a look at it, is it works for Mac OS 10 and Windows and Linux. And what it gives you is an integrated editor and terminal and a whole bunch of really useful packages. You don't have to use VS Code. If Atom or Notepad++ or Sublime is more your way of thinking, that's great. But play with them. Install them. Do a demo. Do a tutorial. Watch a 5-minute YouTube clip. Do something so that you can respond in the following way to me. And this is what I want sort of as the assignment. Send me a message on Slack as a direct message with whatever you've got set up. Okay, so for example, this might be your answer. Okay, I'm using a Windows 10 machine. That's what I use. I'm using WSL version 2, that version of Ubuntu, and I'm using the preview version of Windows Terminal as my main terminal application. Tell me what your GitHub account is. Confirm for me that you know what version of Git you're using. Tell me you've chosen a text editor, and tell me that you've tried an external integrated development environment like Visual Studio Code. You're like, yeah, I'm willing to learn this. And finally, you should figure out how to go from the terminal, okay, In the same way that I can go into my data right here and have some notes, I should be able to both edit a file right in the window, and you should also be able to go right from your terminal and jump to VS Code. And you'll see that the nice thing about VS Code, Windows Subsystem for Linux, is it just does the auto install automatically. So even though this file is sitting on my Linux subsystem, I'm able to access it and edit it in a graphical environment on my Windows machine. And that can be pretty powerful. The fact that you've got a terminal and file system all the way through. So play with one of those, get that set up. That's sort of the deliverable on that piece of information. Okay, and I'll give you a check mark, whatever. We'll call that assignment number 1. Now, that's sort of just a setup of, could be assignment number 0. Now I got too many windows jumping around. Okay, I'm going to give you an assignment number 2. And I'll just release this one right now. I'm just taking the same example that I did from last year. And this will give you a chance to practice some of these. How do I do this? I want to edit the HTML. No, I want this. I want all this stuff. Copy, assignment, upload, create a file. Okay. Okay, it's now 2021-05. Today is what? This day. There. A week should be plenty for us to be able to chew on this. So this is just a standard example. Save and close. Okay. So this is assignment number 2. This is basically a piece of work that is based on using the Unix shell. And I've taken this from a colleague of mine, Ryan Abernathy. He's posted it under a license. It's saying, okay, well, here is some data that's available from somewhere. You're going to download this file. Incidentally, just to download the file, here is a hint. I will give you a hint. Try using only the command line. So you'd want to do something like wget unzip. Okay. Right. So this would be, you don't type in the prompt, right? This is the prompt. These would be like the kind of lines that you would do to get it. No, that won't work. That won't work. I apologize. I don't like bright space. Copy link. Copy link. Paste as plain text. I think that will do it. I'm just going to check that and make sure it will do that. Problem with code. No file or directory. I'm confused. I don't know why my link isn't working. I bet it's just because I'm copying and pasting it wrong. Copy link. Yeah, we'll do it like that. I'll recommend that as the magic incantation. There. I just must have typed it in incorrectly. Save and close. So on a command line, you can download a file. Like, I know you can download the file and use the browse, but we're trying to practice doing everything on the command line. So this link is a hyperlink. You can, on the command line, use the program wget to go get that file. and the command line program unzip to unzip it. Right? Unzip that file in a terminal. What I want you to do is use a program called less, which you can read about, or head to take a look at it, and try and complete the following sequence of questions using bash and programs like something called grep, head, less, tail, unique, sort, cut, right? These different ones, and see if you can figure out these things. Put your answers, as in what your code is, into a file that you're creating called a2_answers.txt. And what we're going to do is I'm going to have you load that answer into GitHub to share your answer with me. We'll talk about GitHub next time, because you obviously need to learn how to do that. But you're welcome to start playing around with this assignment over the next few days and try and figure out if you could use bash and shell scripting to answer these questions. I'm sure you know how to do it with a spreadsheet. I'm sure you could do it in another programming language. The challenge here is to learn how to do this type of analysis, counting columns, things like that, using the Unix shell and the sort of set of tools that might be around it. But there you go. There's the take-home exercise for this week. Okay, we've been going on long enough. I'm done. I'm sure you guys are done too. This is a long time to chat. Okay, so hold on. People are now asking me questions. I want to make sure I answer those before we go. Okay, how could one access the recorded video? So I'm recording it. As soon as it is done recording, what I will do is I will upload it to an unlisted video to YouTube, and I will post the link both here in Slack and on a page of classes or video recording lectures for you to access. So it'll be an unlisted YouTube link is how I'll get it available to you. Not that I think you want to sit down and rewatch 3 hours, but maybe there's something. Next question, Karina. Instead of installing Ubuntu, would MOBA Xterm work during this course? So, Karina, MOBA Xterm to me looks like a terminal application, not a full-blown system. Do you already have MOBA Xterm? Is that why you're asking? You have to excuse me. I haven't. Let's find out. Okay, MOBA Xterm is an X server. It's not the application. So MOBA Xterm is a good alternative to Windows Terminal, but it doesn't replace the machine you have to connect to. You still need to have something you're going to log into. So you could use MOBA Xterm instead of Windows Terminal. That's okay. But you definitely need to at least try to set up a local environment. And I said, if it doesn't work and you end up using my server, or maybe for Karina, if you have another machine you're already using that you connect to, you could just tell me what that machine is. That might work for you because you're using MOBA Xterm to talk to something. Well, what kind of machine are you talking to? That could be your answer. That'd be okay. Okay. Arnab, you asked, are there 2 assignments this week? Yes, I should just call them assignment 0 and assignment 1. The first one is just setup, right? It's a non-trivial, it's a trivial assignment. Sure, the machine you work at the lab is just fine. I'm just trying to give you stuff to work on to be able to do it. And let me see if there's any more. Oh, someone says their system had hanged. Hope you recorded the video. It says it recorded it. I'll stop talking and take a look and see if it worked. Hopefully it did. And I'll upload that. It's like a 3-hour recording, so it might take me a little while to upload that file. The internet that I have is not fantastic. You'll notice from the lovely library behind me, I'm currently in my house. I don't know about the rest of you. Some of you are in St. John. Is anyone not in St. John's? Is anyone remote? So at least a few of you are from somewhere else. It turns out I'm not in St. John's. I went to visit family like 13 months ago in Ontario, and I haven't left yet. So I'm not in Newfoundland either. But I'll get back when we're allowed to travel again. Um, all that other kind of fun stuff. Anyways, okay, I think that's tons of information for today. Thanks very much. I will see you on Thursday. If you do have any questions, just use the Slack channel openly if it's something you think someone else will care about, or privately through a direct message. Other than that, we'll see you on Thursday, and we'll tackle Git and GitHub and all those kind of fun things. Have a great one.